Thank you once again for watching my video. My name is Mr. Taswanike. In today's video tutorial, we will be discussing on difference between NPN and PNP transistor. So that is the topic of today. In my previous video, we have discussed on introduction of transistor entirely, and I also discussed on PNP and NPN as well. If you have not watched the video, please go to my channel, Charles Electronics Tutorial. You will see a video on PNP and NPN, which it was named, or it is named, BJT, being bipolar junction transistor. I have made those videos, and every other videos are also there for you to enjoy. But before we proceed on today's video tutorial, please, I would like to say, if you like my video, subscribe to my channel, comment, like, and share. Just as I said before, today's topic is difference between NPN and PNP transistor. I know I believe that some of you know the difference and some of you don't also know. So that is the reason why I have to make this video for those that are still hunger of electronics tutorial, for them to also understand the difference between NPN and PNP. Definitely during the practical time, which I will use my meter to differentiate, then using meter to differentiate NPN and PNP, I will also educate you on how to do that, so that anywhere you find yourself, maybe you are in interview ground and you were asked to differentiate the NPN and PNP using your multimeter, you can as well do that. So that is the most important thing so far. But before we get to that practical stage, I believe that this one is also very important for you to know the differences, how it works, what are the principles that are behind the PNP and the NPN. So that is the reason why I have to make this video for you. So let's proceed on that as well. One of the major differences, or one of the major difference between the NPN and PNP transistor is that in the NPN transistor, the current flow between connector to emitter when the positive supply is given to the base. I repeat, one of the major difference between the NPN and PNP transistor is that in the NPN transistor, the current flow between connector to emitter when the positive supply is given to the base. You remember that this NPN here that you are seeing, it signifies negative, positive, negative. So what I'm trying to explain here is the current will flow from connector to emitter, and that bit that is in between the NPN is the positive. That is why I say when the positive supply is given to the base. So the positive supply is being this B here, being this base. That is what it means by base. So that is what I meant by that. So in that case, let's proceed further as well. Whereas in PNP transistors, the charge carrier flow from the emitter to connector. Remember, the NPN, it means that the current flow between connector to emitter when the positive supply is given to the base. While in PNP, the charge carrier being the current flow from the emitter to connector. When the negative simply means this N here stands for negative, while this B here stands for positive, negative, positive. When the negative supply is given to the base, that is so say that the negative is still on that N. N stands for negative and is also the base between the two PNP. So that is just the number one difference for you to understand. And I believe that I have more differences for you to get what I am saying properly, and I believe that you will not be confused, because this video I make it easier for you and I, so that you will enjoy it and also look for more. So in that case, the NPN and PNP both are bipolar transistor. The NPN and the PNP both are bipolar transistor. It is a current control device and mainly used for switching and amplifying the signal. It is current. It is a current control device, while the other FTC is a voltage control device. PNP and NPN, both of them are current control device, and which it is used for switching and amplifying signal. So most NPN transistor is used in circuit, because in NPN transistor the conduction current is mainly by electron. The conduction current is mainly by electron. It simply means the conduction current between NPN, being electrons stand for negative, while holes stand for positive. So the reason why this the most NPN transistor is used in circuit is because in NPN transistor the conduction current is mainly by electron, while in PNP the conduction current is because of the holes. Just as I say, holes are positive while the electrons are negative. As the electrons are more mobile, than the holes. The NPN has high conduction. That is to say, the NPN is more used than PNP. Let me use it in that way, in that form, so that you will not misunderstand it. So in that case, I will also show you some symbols and explain it a little bit more to your own understanding. The letter PNP and NPN shows the voltage required by the emitter, connector, and base of the junction transistor. The NPN and PNP transistor both are made up of different material, due to which the current developed in them also differ. It is because the two components are made in different material, and the current that they accept or take in, the current is also different from each other. That is what I mean by that. So in that case, I want to show you something. This is what I want to show you. These are the negative, positive, negative. It means NPN. NPN, I have been saying this, is negative, positive, negative. That N that you're seeing there is negative, while the P is positive and the N is also negative. So remember what I discussed or what I said before. Based on this base is the positive, while and while the emitter and connector are the negative junctions between the positive. For instance, you can also see at this area where you can see negative, positive, negative, which is a emitter base connector. If you also look down where battery has been added, because I really want you to understand this. From the connector aspect of it, that is where the revised bias is. While in terms of the emitter, it is where the forward bias is. So that is to tell you that in connector, it has revised bias, and in emitter, it has forward bias. I believe you understand what I mean by reverse bias and forward bias. Reverse bias, let me just make it formed, and let me take it in a short form. Reverse bias is just in a blocked mode, while forward bias is when the current is delivering to each of the components or each of the legs from base to emitter or to connector, depending. So another one here that you can see is direction of current. Direction of current, which you can see the arrow. The arrow is already there. Look at the arrow. The arrow is pointing at the emitter. The arrow is pointing upward, looking at the emitter. That is to say that the current is flowing. The direction of current is connector to emitter. That is what it simply means. That arrow that you're seeing is telling you that the current will flow from connector to emitter when the positive terminal is in that base. That is the P. That P represents the base, and that is the positive terminal of NPN. I don't know if you really understand what I mean here, but if you don't understand as well, you can also comment below. So in that case, here is the positive, negative, positive, positive, negative, and positive. That is to say PNP. In PNP, I will start from here. In PNP, the negative here being the base is the N being the negative, while the emitter and connectors are the positive. So from the arrow, you can see that the arrow is pointing down. That is to say that the current is moving from emitter to connector, while in NPN, the current is moving from connector to emitter. Now, it means that the thing is revised bias. Is now revised because of the arrow. The arrow is what is the thing that also tell you the direction of the current. It shows you the position of the current, how the current is moving, because NPN and PNP, they are current control device. So in that case, you can see that one of these emitter is positive, the connector is also positive, while the N is the negative, being the base. So let's come to here. Here it simply means when battery has been added, let's say when voltage has been added. Now for here, it means that the connector, being the connector here, being the positive area of the space, is the revised bias, just the way it is on that NPN. Here it is also forward bias. If you watch out the circuit properly, you will understand what I'm saying. Why in this between the NPN we have the negative being the base. So the base is always there for each of them. So that is to say that in a situation like that, we can also define both the NPN and the PNP. That NPN transistor, in which NPN transistor defined in which two n-type layer are separated by two p-type layer, which is called NPN. It simply means that two n-type is separated by one of the p-type of material. That is why it is called NPN. It is called negative, positive, negative. The same thing applies to positive, negative, positive, which say two block of p-types semiconductor are separated by one thin block of n-type semiconductor material called PNP. So these are just how I want you to get it for you to understand it properly. So I believe you also understand what I mean by NPN, PNP, and so on and so forth. So in that case, I would like to also give you some brief differences a little bit before we move further. So the connector base, I want you to understand this. The connector base junction of NPN and PNP transistor is connected in reverse bias. Now, I want you to understand this. It means that the connector base between the NPN and PNP, they are all connected in reverse bias. Look at this here. It is connected in reverse bias. Here is the connector base. Here, in terms of the PNP, this one is the type of PNP. Let me also show you the NPN. Look at it here. It is also connected to reverse bias. So that is to say that the connector base, both the NPN and PNP, is connected in reverse bias. That is what I meant there. So I also want you to note something here. The forward bias junction means the B terminal of the transistor is connected to the positive terminal of the supply. I don't know if you really understand what I mean here. I repeat. The forward bias junction means the B terminal, just as I said before, the forward bias, this is the forward bias junction, which I really want you to understand. The forward bias junction means the B terminal of the transistor is connected to the positive terminal of the supply, and N-type material is connected to the negative terminal of the supply. This one, what they are trying to explain here, if you watch it properly, it is obvious that from what I am saying here, from the forward bias, they say from the forward base junction means the B terminal of the transistor is connected to positive terminal. Look at it here. It's connected to positive terminal. Look at the positive terminal here. It has terminal here. This is the terminal, and the N-type material is connected to the negative terminal. The N-type is also connected to the negative terminal. So that is to tell you that both the P-type connect to positive, while the N-type connect to negative. So let's move forward on that. Another note that you should also bear in mind is this. The reverse bias means the negative region is connected to the positive. The negative region is connected to the positive. If you have seen it, the negative region is connected to the positive. The is connected to the positive terminal of the supply, and the p-type region is connected to the positive terminal of the supply. So it's obvious that you should also know what I am trying to say here. So those are the difference in terms of noticing anything here. So you can see that the 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 reverse bias between the PNP and the NPN, the both connector bases, they are in reverse bias. Why? In terms of the emitter, they are all in forward bias. So that is to say, as it is here, the reverse bias means the negative region is connected to the positive region. So it means it has been rotated. The negative region is connected to the positive region terminal of the supply, and the p-type region is connected to the positive terminal of the supply as well. So that is just how it is. So let's move forward again. Let's move again. You say the ground signal of the NPN, the ground signal of the NPN transistor is kept low, whereas in PNP, the ground signal transistor is high. So in terms of NPN is low, the ground signal is low, while in terms of PNP, the ground signal is high. So the emitter-based junction of both the NPN and PNP transistor is connected forward bias. It's just as I said before, while the connector, both the NPN and PNP is connected reverse bias, while the emitter base is connected forward bias, both in NPN and in PNP. Another one says the NPN transistor turns on when the small current flow from emitter to base. It turns on when small current from emitter, being from emitter here to base. I don't know if you understand exactly what I mean, because some of you will be saying, what is he saying? This guy, I don't know, but that is just how it works. I repeat, the NPN transistor turn on when the small current flow from emitter to base. The current will flow from emitter to base in terms of NPN. Let me bring it back. The current here flow from emitter to base. That is in terms of NPN. Whereas for turning on the PNP transistor, the small current flow from base to emitter. So what I'm trying to say here, I want you to understand this. In terms of NPN, the current flow from emitter to base, while in terms of NPN, the current flow from base to emitter. It flows from base to emitter in terms of NPN. Now let's move forward a little bit again. The inside current, NPN constitutes because of the varying position of electrons. you get that the inside current NPN was constituted. It was constituted because of the electron, because of the position of the electron. Whereas in terms of PNP, the inside current is because of the very position of the hole. So the two difference is NPN is electron, while PNP is hole. So in that case, in PNP transistor, the current flow from connector to emitter because positive supply is given to the base. Whereas in times where in PNP transistor, the current flow from the emitter to connector, from emitter to connector. I've been explaining this over and over and over and over and over. So that is what I just said now is in terms of direction of current. It flows from emitter to connector, while the other one flows from connector to emitter based on the arrows, based on this particular arrows here. The arrow will signify where the current is flowing in terms of current direction. That is what I meant here. So I believe that we are making progress on this video. So let's also move ahead on other ones. In PNP transistor, the output current exceeds because flow of holes, and in PNP it is constituted because of flow of the electron. So in terms of this, that is in terms of the output. In terms of the output, the other one I say was when it has been constituted inside. Why this one is the output? Output is the process where the emitter or whether NPN or PNP is meant to deliver exact voltage that is supposed to deliver to other components for the circuit to be circulated with current or voltage. So that is what I meant here. In terms of the output, this is how it works. Now it has been in revised bias altogether. In NPN transistor, the output current exits because flow of holes. While in PNP, it is constituted because of the flows of the electrons. So those are the things that you also need to understand. Why in PNP, the switching time is faster as in PNP, the switching. Okay, in NPN, the switching time is faster, while in PNP, the switching time is slower. So that is to say that in terms of switching, PNP is lower in terms of switching. It's very slow in terms of switching, while in terms of switching, NPN is faster, and that is why majority of electronics you will see NPN. So let's just look for our other ones. I really want you to get this thing in depth, absolutely, so that you will not misunderstand everything I say here. This is PNP transistor turn on and off state. This is on and off state. Now we have transistor not turn on. It means emitter supply voltage. Transistor not turn on, emitter not supply voltage. Remember that the current itself will flow from where? From where? Emitter to connector. While in terms of NPN, it will flow from connector to emitter. Bear it in mind. So in this place now, it means that base emitter, while once the thing is not delivering any voltage or any current, this is the symbol of PNP. You have saw it before, so I just want to add it more to you. So this is how it is. And once this here is the not on state, so there is no current here, there is no current passing. While in terms of on state, you can see that base is 0.5 volts, it's a small current, is 0.5 volts. Emitter here is also 0.5 volts. This base emitter is 0.5 volts as well. Both of them are 0.7 volts, 0.7 volts. And that is to tell you that this arrow that you're seeing is greater than, it means that it's greater than that. So that is a symbol of that. So in terms of that, you also see the NPN. Take your time to watch this carefully and understand how it works. So in terms of the NPN, even on the turn off state, the base is delivering 0.7 volts. Even on turn off, when the thing is not even on, it has 0.7 volts. That is how it is. Both of them have 0.7 volts. The same thing apply in times of turn on state. It also have 0.7 volts. Here the arrow changes. That is why we have inequality. We have greater than. Here is greater than, while the other one in terms of the PNP is less than 0.7. For in terms of NPN, it is greater than 0.7. So these are just things that I also want you to understand in how the difference between the transistor and the PNP transistor and the NPN transistor. I believe that if you don't understand it once like this, you can also watch the video once again to understand. And if you don't really understand what I just say, you can also comment below. Then let's look for a way on how to make you understand exactly what I am saying. And I believe that you have learned something from it. Please, I would like to say, if you like this video, give me a thumbs up, subscribe to my channel as well, comment, like, and share. Thank you once again for watching. See you next week.